Morning, everyone. This is Craig's story from Cirrus Research. Welcome to everybody who's joined. Just a reminder that everybody who has signed up for this will get a link to the video once it's been edited and all the rubbish bits taken out at the end. You should get that in a few days after this presentation. So welcome to this webinar. It's called Understanding and Managing Hand-Arm Vibration. I'm Craig Story from Cirrus Research. I've been with Cirrus Research well over 12 years now. My job is to basically sell and to consult with various businesses on noise, vibration, and other environmental aspects of their business. I've toured the country, visited many businesses, and hopefully a little bit of experience that I've got will be helpful in getting some understanding for you all today for this particular seminar. So without further ado, we'll make a start. If you've got any questions at all, please add them. I'll try to answer them as I go along, but if not, I'll answer some of your questions at the end. The talk today should last about an hour, something like that. It depends how fast I rattle through it, of course, and what we'll do at the end is we've got until 11:30 to answer questions, and then you will see all of this, as I say, in a link to this video on neatly packaged once we've completed it. So a very warm welcome to everybody. Thank you for attending, and without further ado, let's get on. I'll put me in the bottom here. I may be taking myself off from time to time, depending on what slides we've got. So today we're looking at understanding and managing hand-arm vibration in your business, and we're going to take a quick look at what we're going to cover today, because there's quite a few things to get through, and I hope this will be very useful for you. So first of all, we're going to look at hand-arm vibration, what it is, how big of a problem is it in this country and across the world. We're going to have a look at the regulations that apply to this particular health issue, the Control of Vibration Regulations 2005. We're going to look specifically in quite a bit of detail at that, because what's important is that it's not just the fact that the regulation's there, but it's really understanding what they mean for you and your business and how to comply with them in the best possible way to make sure that you're securing the safety of your employees. So we're going to look at the limits. We're going to take a quick look at how we measure and what vibration actually is. And then we're going to spend a bit of time looking at what your duties are as employers, and then look at risk assessments, and then putting some sort of a strategy in place that's going to make sure that you're managing that risk within your business. So hopefully you'll find it useful as we go along, and plenty of questions would be really useful. And you never know, I might answer all of them as I go along. So the first thing we're going to look at is what is the actual issue that we're dealing with here. And I'm sure I'm talking to everybody that knows quite a bit about this already, but there is a health risk to using any sort of vibrating tool. And this risk comes from the vibration that passes from the tool into the body. And that's where you're primarily handling the tool. You're holding on to something. It's a vibrating tool because it needs to be to do its job, whether that's a sander or a drill or whatever it happens to be. And that vibration, because you have to handle the tool to do the job, is going to pass into your body, and that can cause damage. The problem is, once that causes damage to your body, primarily the sort of the hands, wrists and the arms, that damage is basically permanent. It's not something that you can easily reverse. Once the damage is done, it's actually done. But the good thing is, of course, it is completely preventable. Unfortunately, unlike, for example, noise, effective PPE for vibration is basically non-existent. We'll cover this as we go along, but there are certain things, yes, you can do to mitigate, but in terms of PPE, it's not something that you can put all of your faith in. With noise, for example, you know that if you wear the correct hearing protection and you wear it in the correct way, then that damaging noise isn't going to get through and damage your ears. There's lots of issues around making sure that PPE is worn correctly. It's a difficult management task, but it is effective. It really is. But with vibration, it's completely different. It doesn't actually stop it. One of the other important things to note about hand arm vibration, in relation, again, keep going back to noise, halves is actually reportable under RIDDOR. So if somebody comes to you with hearing damage in 5 or 10 years' time and say, look, you didn't manage my workspace or my working life appropriately, you ignored us, I've got some hearing damage, then yes, there could be a claim, obviously, but that's not something that is necessarily reportable ultimately to the HSE. But halves is reportable, so it's actually at that next level. When you look at the numbers of this, then it can potentially affect up to about 2 million people in the UK. I'll just get rid of me for a second here. So you can see the full slide. It could potentially affect about 2 million people. That's obviously going to vary. It could be even more, but people are using vibrating tools, and there's some potential damage there that could affect them. And if you look at the numbers again, vibration white finger and carpal tunnel syndrome, which are two of the effects which we'll come on to from hand-arm vibration, they are the second largest category in the IADB after lung-related diseases. So it's an important subject. People are getting damaged, and we need to do something to mitigate this. Hence, these sort of webinars and general information. So it's a big issue. So let's have a little bit of a history of this. Hand-arm vibration is generally a fairly modern disease, shall we say. It's only come about really with the effect of more hand tools, tools that are smaller, tools that people need to actually physically hold to do their job. It originally came to light where I think it was people in the lumber industry. They were using chainsaws and things like this. People noticed that they were getting something called vibration white finger, and that's an example there on that picture, where the ends of your digits start to go white. They're not getting a good enough blood supply, and eventually it was known as hand-arm vibration syndrome. And the first international standard came along in 1989. So in relation to noise, specifically, it was sort of falling a little bit behind. But these days we have the Control of Noise at Work Regulations 2005, which covers this pretty comprehensively. And as you can see by the date there, that's been around a long time. So what are the effects? Well, hand-arm vibration, because people that sort of tend to know it as more of just vibration white finger, it's more than that. There are three basic components to this. The number of different components are three. It's the vascular component to this, which is basically the blood vessels. So you've got a disease already called Raynaud's disease, where people's extremities, their fingers and the toes, in cold weather, the body has a reaction where it tends to constrict the blood vessels at the extremities, because your body wants to keep the blood supply to your core and keep your body warm, so it sacrifices the extremities, the ends of your fingers and things like this. So it's got your blood supply more into the core of your body to keep you warm. So that's already a known disease that some people have. But we term vascular because it's basically the blood vessels which are affected. So it's similar to Raynaud's phenomenon, and it's called vibration white finger, and that's where your body has difficulty in getting the blood supply to the ends of your fingers. And sometimes this can affect many parts of a digit, So it could just be the end joint or the middle joint, or sometimes even the whole fingers in very extreme cases. And of course, in extreme cases, this can lead to tissues dying, etc. So that's the vascular component to it, and that's the one where most people seem to have some sort of recognition, and they've heard about it, that sort of thing. There are also two other effects of hand-arm vibration. One's neurological, which is obviously the nerves. So you can get a numbing sensation, tingling, a loss of dexterity. You can't feel things very well. That's where you can get damage to the nerves because you've been exposed to too much vibration over too long a period. And then finally, you've got a musculoskeletal, I have to say that slowly, part to this. And this is where you've got things like carpal tunnel syndrome. This used to be a one that came out years ago, I think, people not having their hands on their desks to use their keyboards properly, they're at funny angles. But hand-arm vibration can cause carpal tunnel syndrome, it can cause damage to the joints, and you can get cysts on the joints and things like this. So it's not just the VWF, the vibration white finger. There are quite a few other effects and symptoms associated with vibration white finger. So early symptoms can come along. It's something that any business needs to look out for in people that are particularly using hand tools. One is tingling and numbness in the fingers. People start to get that, where you're not able to feel things properly. So you touch something and you can't quite sense it's there. Where you've got a loss of strength in the hands, then your grip isn't quite as good as it used to be. And of course, the obvious one, where the ends of your fingers become white, and then obviously once you recover and the blood starts to flow again, then become sort of red and painful and swollen. Particularly, it sometimes just happens in the tips of the fingers, but obviously it can, as I said before, it can move down through the joints, so that eventually, whole fingers could be affected. And of course, symptoms can come on. Generally, they don't come on immediately, but they could come after a few months of using hand tools if it's a severe case. And typically, these symptoms will come on after a few years of using those sorts of tools. So it's always wise in your organization to make people aware of reporting any early symptoms of like these that might be happening with their hands, particularly if they're using vibrating tools. Different ways of measuring the effects of hand-arm vibration, different, shall we say, scales for vibration white finger, various tests for neurological nerve conditions, where you can get them to detect vibration, detecting temperature. So there's different scales, different obviously levels of severity of this. Tests for musculoskeletal issues like grip strength tests, and various tests for carpal tunnel syndrome as well. So there are ways to test people to see if they actually are starting to develop symptoms that are related to hand-arm vibration. And this all comes into part of a health awareness, which we'll come on to a bit later on. So let's have a quick look at the legislation then that applies to all of this. Our control of vibration at work regulations came in 2005. It was based on a European Union Physical Agents Directive from 2002. It actually covers hand-arm vibration and whole body vibration. We're not talking about whole body today, but if you can get in touch with me if you want some information about measuring or any information about whole body vibration, but we're just going to concentrate on hand-arm vibration today. It became effective in all EU member states, and obviously we were part of the European Union at that time, and those regulations still apply. And some of those provisions didn't fully comply until about 2010. But even so, we've been under these regulations for a long time. So every business should be aware of them, and it's obviously useful when you're picking up extra information or reminders in webinars like this, just to keep your information up to date. So it's nothing new, but you would be surprised sometimes at how many businesses that I come across that, are only sometimes now starting to think about, well, maybe we might have a problem. So it is important to take this matter seriously, because believe me, the HSE do. So here's the regulations there. You'll see the picture of the booklet. Like the noise one, it's very well written, easy to understand, and you can get a lot of very, very useful information in there. And basically what I'm doing today is I'm summarizing a lot of this information for you, and trying to put a bit of emphasis in the areas that I believe are particularly important. So what does it do, the control of vibration at work regulations? Well, it basically requires employers to prevent or reduce the risk to hand-arm vibration from the tools that people are using. And it has a number of basic elements to it, summarizing it very, very briefly here, of course, but it just pulls out the main ones. First of all, you need to assess the risk from vibration to your employees. So you need to know who is potentially at risk and what that particular risk is, and we shall cover that. The next part of it is once you understand that, is taking some actions to reduce people's exposure to that risk, because that risk isn't going to go away unless you can think of a completely different way of doing those particular tasks that don't involve tools that can pass vibration on to the person that's holding them. So you need to take some actions to reduce that exposure. And again, we'll cover what those actions might be. You need to make sure as an employer that the legal limits are not exceeded. That's very, very important that you're doing that. And you need to also make sure that you're bringing your employees along with you. So what you're doing is you're providing information to people, training on a wider range of topics, not just about what HAVS is, but about how you're managing that risk within your company and what you're expecting them to do. So that's absolutely key. You need to also carry out health surveillance. So this is something that obviously, if you've got people who are potentially at risk, then you need to keep an eye on them and to make sure with those various ways of reporting and tests, etc., that they're not starting to suffer from the effects of hand-arm vibration. And with all of these regulations, you need to keep records. So it's not good enough just to say, yeah, everything's okay, or we've put this in place, but you need to make sure that record keeping is as good as it can possibly be, so that you're ensuring that the processes or whatever you've put in place is documented, and any testing, etc., that you've done is documented. So keeping records is a really key thing. So I mentioned the control of vibration at work regulations, and one of the things that it covers is basically how do you know that anybody is at risk, and we do that by looking at somebody's hand-arm vibration dose. So what that is a way of quantifying what somebody's risk is in terms of how much vibration that they are being exposed to on a daily basis. And we do that by relating that exposure to a standard 8-hour day. So if anybody knows a little bit about noise, it's a similar thing. It's all related to a standard 8-hour day. So if you work longer than 8 hours in a day, then you're obviously exposed to more vibration, and the calculation means that your risk is higher. And if you work less than 8 hours in a day, then subsequently that risk is slightly lower. But you need to be very careful about calculating what that exposure or that dose is for your individuals. So there are two limits basically within the control of vibration regulations. We've got an action value and a limit value. So I'll come on in a second as to how we know what these values actually are. But I'll just tell you what they are at the moment. So we've got an action value of 2.5 meters per second squared. And that is basically acceleration. And that's what we measure vibration in. We measure it in acceleration. So we've got a low value of 2.5 and a limit value of 5. So basically what happens is anybody whose level of vibration exposure over an 8-hour day is less than 2.5, then they're not at risk. If they're above the top one, 5, the limit value, then they're definitely at risk and you need to bring it down to below 5. And if you're between those two limits, between 2.5 and 5, then you're potentially at risk. And then you're still in this program of awareness and mitigation and things like this. So the duties are cumulative. And this is something, when you're using the vibrating tools, every day can be potentially different. People are using different tools for different jobs on different materials. It's a very, very difficult thing to manage. I'm not saying it's easy, but it's something that it's something you definitely need to keep on top of. And it is becoming a more serious topic. When we were at the recent health and safety show at the NEC, we got as many people coming up to talk to us there about hand-arm vibration as we did about noise. So it's a very key thing amongst many companies. As I've explained before, the HSE are very, very keen on making sure that everybody complies with the regulations. So those are the limits. So let's have a little look then about vibration itself, just so we're all on the same page with exactly what it is. So vibration is basically a cyclical movement of a solid body around a stable position, an equilibrium position. That's something that's moving sort of backwards and forwards around a fixed point. Lots of things vibrate. You wouldn't even know they were vibrating. Every time you hear a sound, some surface has vibrated, for example, to create that sound. But these vibrations, as we know, can have a very direct effect on the human body. They can even, if they're powerful enough, they can damage structures and equipment. But we're not talking about those sort of vibrations. We're talking about vibrations that you're going to pick up through how you're holding that tool through your hands. And the vibrations that you are picking up are a mix of different frequencies. So you get some sort of higher frequency and some lower frequency vibrations, all coming through at the same time, depending on what tool you're using. And some frequencies damage our bodies, the research has shown, more than others. So for hand-arm vibration, the frequency range, we're talking anywhere between 2 hertz, 2 cycles per second, and 2 kilohertz, 2000 cycles per second. But the most significant range of frequencies that does the damage is between 10 and 250 hertz. And those are the ones that we're most keen on looking out for. But it's not just steady state, because anybody who's used a tool will know that tools, the vibration varies. So if you've just got a tool idling in your hands, it's not under any load. If it's a drill, it's just you're going to get a certain amount of vibration. As soon as you start using that drill on a particular material, then the vibration is going to start. And there are lots of things that will determine how much vibration you're going to get. So, is the drill bit sharp enough? Is it a different type of steel you're drilling through? Is it wood? It's even on who's actually doing the drilling. You would be surprised at how much difference there is in the vibration that people receive, depending on who's actually using any one particular tool. Some people are more efficient at using them. They've got a better way of using that particular piece of equipment, more experience or whatever. So it is variable. And sometimes you can get shocks, which means sort of, high vibration values, which can happen over a very short period of time. Then it goes back to more of a steady state. So there's various sort of different components of this. To measure vibration, of course, which is what we need to have some form of measurement of vibration. The primary thing that we use is acceleration, meters per second squared, ms to the minus 2, as you see it on there. So that's one way of measuring vibration. It's the acceleration. You can also measure the velocity and the displacement. So for acceleration, but in terms of the legislation, the regulations, where it's all based on acceleration. And then what we do is, if we were to measure this, then we're interested in the acceleration in 3 axes, in 3 different directions. And there's a little diagram on the screen there which shows you how that's measured. So we're measuring the z-axis there is the measurement sort of through the front of the hand and up the arm. The y-axis is basically the side-to-side movement, so it's along the handle. And the x-axis is up and down, so your hand sort of moving up and down if you're holding the handle. So acceleration, i.e. vibration, comes at you from 3 different angles. So we measure it in 3 different, in 3 different dimensions. And then basically what we do is we add all those 3 vibration values together to get a sum. And it's the sum of all those vibrations in all the different directions, the 3 main directions, that we actually use as our vibration value. So, for example, if you were buying a new drill, generally speaking, or any sort of vibrating tool, it will usually have some sort of vibration value, an acceleration value listed on there. Sometimes it's just a general value, sometimes it's values of acceleration based on different materials that you use it on, but it's usually the summed value that you get. So that's important to understand that. So this is what we're doing. We're actually, we need numbers, right? And we'll come on to what those numbers are and where to get them from, because unless you know how much acceleration, i.e., how much vibration somebody is getting, how on earth do you know whether their dose is going to be exceeded for a particular day? Okay. So we've done a little bit about measuring vibration. We're going to have a little bit of a look now at different employers' duties, and just go through this a little bit, and then we'll come along and sort of pull it all together. So basically, the employer's duties are about these different action levels. So, as I said before, if somebody is below the exposure action value of 2.5 meters per second squared, based on an average working day of 8 hours, then they're basically potentially at risk. So you need to minimize your employees' exposure. That's what you're looking at doing. And then you're going to look at a number of different ways of doing that. You're going to look at the equipment that they're using to do a particular job. You're potentially going to look at their workstations, the design of it. How are they doing it? What is there a better way of actually minimizing the amount of vibration that somebody's getting there by doing the task in a slightly different way? Or do they actually need to hold the tool? Can there be some sort of mechanical way of using that tool with some minimizing the amount of touch that you've got on it? So this is the sort of things you need to sort of think about. But the main one is all, if you can't make any of those changes, it has to be this tool, it has to be done in this way, etc., etc. It's all about limiting the exposure duration, which basically means limiting the amount of time that somebody is using that particular tool or that set of tools. Okay, so that's basically what you're looking at. If somebody is above that action value, which is the lower of the 2 values, you're still into that process of minimizing the exposure, because it could easily creep up. So you do need to start thinking about these things. You also need to provide protective clothing. Now, let me talk a little bit about this, because as I said right at the beginning, then there is no effective PPE for hand-arm vibration. I know there's, people will sell anti-vibration gloves, and to be honest, the jury is really out on that, because they tend to be thicker, and they may provide some protection for some frequencies, but sometimes people are using these gloves and gripping the tool even harder than they were before, and it's still letting different frequencies of vibration through, sometimes even more than before because of the way they're holding it. So they're really not effective. But one of the key things that people have found with vibrating tools is that if you keep people warm and dry, particularly their hands warm and dry, the effects of the vibration on their hands is not as bad. I wouldn't say the word minimized, but not as bad as if they were cold and wet. So we've seen some companies that provide sort of hot air blowers outside for people, not to dry their hands necessarily, just like you find in the toilet, but just to make sure, if their hands are getting cold, to warm them up when they're outside, just so that they can keep their hands as warm and as dry as possible when using vibrating tools. Because we know if you do that, then that will minimize some of the risks. It doesn't mean to say that you can still expose people to more than the levels that we mentioned. Excuse me, not at all. But it does have that it can have that effect on minimizing the effects. You do need to provide lots of training and information to people, as we've mentioned before. You do need to provide health surveillance, and you do need to keep records for potentially up to 40 years, which is quite a long time. And it is the duty of, we all talk about employers' duties, but it is the employee's duty to attend these and to take part of them. So they can't just say, great idea, but I'm not interested. It is something that they are obliged to take part in. So all of this is all sort of standard stuff. It's all about minimizing it. But let's see what happens if we go over the limit value of 5 meters per second squared over an 8-hour working day. And the regulations state this must not be exceeded. Okay. If it is, then you have to reduce that exposure immediately by whatever means you can. Easiest way, reduce the amount of time. You need to investigate why it's occurred, and you need to take positive steps to prevent it happening in the future. So that's something you definitely you need to look at. So if somebody's overall exposure limit is higher than 5, then you need to get really serious about it. If, because of the nature of the work, it occasionally exceeds the limit value, then you could look at a weekly average. That's something you can do. Similar to noise, you can look at a weekly average for these things. But you may, because you might have days where there's not much vibration exposure, and other days where there's a lot more vibration exposure. So you could look at a weekly average if somebody has to use that tool. You have to be very careful with this. One thing you do need to do, though, is you do need to increase the health surveillance on those individuals, because you are taking a risk with them, because there are going to be some days where they will be exposed above that limit value of 5, and other days where they aren't. So it's always wise to increase the health surveillance on those individuals if you find that the only way to get the job done, as it were, is to put them into that basic position. Then a final slide on employers' duties. It's all about training and information with people. The more you can get people involved in this and understanding what the issues are, the better. So it's about telling people about these exposure and limit values and what they mean at different levels. When you do a risk assessment, letting people know what the findings actually are. Don't keep it hidden. They'll be as keen to know as you are what those findings are. Let them know what measures you are taking to mitigate those risks. Tell them about the symptoms and make sure that they do report them if they do start to get those sort of issues with their hands, the tingling, the fingers going white. They may not go white straight away, but it might be that they'll be doing some other job, or they might be at home or walking the dog or something when their fingers, oh, the ends of my fingers are turning white. They've never done that before. Make sure they report that, because that could be, a result of, what's been happening at work. Let them know about what safe working practices you're putting in place, and then try to get that message across. It's all the usual sort of stuff, isn't it? In a variety of different ways. So whether it's toolbox talks or videos or getting somebody in to talk to them or whatever it happens to be, but that message, getting the workers on the side with you with all of these health and safety issues is a key thing, because that'll make everybody's life that much easier. But it's about understanding, because not everybody has that understanding of the severity of what this issue can cause. This slide direct from the HSE website. I thought I'd bung it in. It just shows you what happens when you've got the vibration magnitude starts to increase, and the length of time you can expose somebody to over a working day. And obviously, if you start to get some very high vibration values from tools, then the length of time that you can actually expose somebody to those vibration from those tools is remarkably short once that level gets high enough, and you can get some remarkable vibration levels. Believe me, I've done some measurements on tools where you can get 18, 20 and higher very quickly, and the length of time somebody can be exposed to that is sort of a few minutes. Obviously, if the level of vibration is below those limits that we've talked about, then obviously people can use those tools all day. It's not all bad, because people aren't using the tools continuously, are they? They're not continuously using, so they haven't got their hands on a tool all day long. They're not drilling all day long. They're doing something and stopping, and doing something and stopping. But there are certain tasks where people do have their hands on tools. Think of polishers and buffers and sanders and things like this, orbital sanders, where people are using it for constantly. But a lot of tasks aren't that consistent in terms of the length of time they use them for in one go. But it just means, though, that trying to work out somebody's exposure, their dose, can be quite complicated. I'll just throw that one out there. So you're going to all ask the question, how do we know what the exposure is? So, or the dose that somebody's receiving? Well, it's a combination of the level of vibration you're exposed to, and of course, how long you're exposed to it. And so there's two things there. It's time, and it's what the vibration values you're getting from the tools that you're using. So as I mentioned before, all tools have vibration values associated with them. The vast majority do. I think it's any tool that's makes above 2.5 meters per second squared has to state what that is in their documentation. So every time you buy something, or you can look on the website, there's a value for that tool. The problem is that is what the manufacturer is saying it is, and I don't want to belittle any manufacturers, but they're more idealized values. Some tools will have, as I said before, different vibration values identified for different materials that you're using the tool on. So, for example, if you're using a drill, if you're using it drilling concrete or steel or whatever else, so there'll be different values. There's different values for different tools. But that's one where you've got to ask yourself, is that information useful? Because and when you do, if you've ever done any actual measurements, that's a picture there of a typical sort of measurement tool to measure the vibration from the tool handle. That's called our Revo vibration meter. So if you ever want to measure the tools yourself, you'd use something similar to that. But because you ask yourself the question, well, hang on a minute, what happens when that tool starts to age? What happens if I'm using a drill bit that's getting a bit blunt, or I've got a grinder and the wheels getting a bit blunt, whatever else? The vibration levels you get are going to be quite wide. So you could look at information on a data sheet from a product and quite easily, you're going to say, well, is that right or not? You can use that information, but I would use that with a certain amount of skepticism and care. There are, however, online databases that are available that you can find with some more real-world vibration values from different tools. So they're, I think, a much better bet. I think INVC has some database. There might be others online. The HSC has some values as well that you can look at, typical values for tools. I haven't put any in this spreadsheet, but they're quite easy to find. So you can get those sort of values and look at those, which will be that little bit different from the data sheets. The final way of doing that is to actually measure the tools that you've got. And that's, as I said, that's a typical sort of example there that we've got. So if you're measuring it, you're saying to yourself, why am I going to do that? Because not everybody wants the expense of doing this on a regular basis. But you've just got to ask, you've got to look at the reality of it, and that whenever you measure a vibration value from a tool, it's affected by a number of things. The person actually using it, as I said, it's, different people will give you different vibration values. The age of the tool, as it started to deteriorate, is a little bit looser inside. It's not as compact and as new as it once was. Are the end pieces, the drill bits, the blades, whatever it happens to be, are they as sharp and as effective? Are you using the right one, for example? And obviously the materials that you're using those tools on, it's all going to differ, and it really does differ. So with measurements, you're actually measuring the tool handle. There are wrist measurements available, devices that will measure things on the wrist. The HSC haven't, as far as I'm aware, sort of recommended you go down that route at all. If you are going to measure the vibration coming from the tool handle, but you will get a range of values. Just because you use a measurement tool to say, right, I'm going to measure this drill, I'm getting 3, and then you take another measurement and you get 6, and you take another measurement, you get 5. You will get a range of values depending on the factors that I've just mentioned. So you really need to be aware of that. And basically, you're talking about using potentially the worst case to do your calculations, because you just don't know when an individual comes into work one day, picks up a particular tool and starts to use it. Some of the other areas you've got to think about, I don't know if there's anybody on here today from workshops, particularly automotive workshops. It tends to be, what tends to happen is people have their own tools. They build up a huge collection of tools, and those tools don't even belong to the employer. And that's another kettle of fish that you'll need to open, because anybody that's using a tool to do their job for you, you need to be on board with what those potential vibration values are. So that's about knowing the exposure. Now, the other thing is about how long you've been exposed to. And I've got some maths on the screen for you, which is amazing, isn't it? I hope you all look at that and lift your hands up in horror. Basically, there's a way of calculating. If you were just doing one task, you'd take the vibration value and you'd use that little square root of the length of time divided by 8. That's what you do. And if you're doing more than one task, you've got a slightly more complicated calculation to do. But basically, I'm not asking anybody to do any specific maths, obviously, because one thing that is good is there's a fantastic HSE online calculator. And this is it. So you can just Google it and you can download it and use it for free. It's excellent. So you can put in your tools, you can put in the vibration magnitude that you get, and you can either use the HSC value that it'll come up with, or your own value if you've measured it or taken it from the data sheet. and then you can say what was the exposure duration. That means how long was somebody using that tool. So you've then got to ask yourself, well, how do I know that? And it's a difficult one. It really is. But and there are a few different ways of doing it. You can buy things that you put on your wrist that will measure when it detects vibration, for example, and at the end of the day, it'll tell you how long you've been using vibrating tools for, so you get an idea. And there are others that will link, and it'll tell you which tool you were using. You sort of pair it with a tool, so you can say, well, it was using this tool for this long and this tool for that long. Do you need to get that complicated? Maybe, maybe not. You could just say, right, well, look, what's the worst case? How long are you using this tool for in a day? Well, and particularly with drills and other tools, you're only using it for a few seconds at a time, but you need some measure of what that exposure is. But if you've got that information, you can use this spreadsheet and it will magically calculate for you your daily exposure. That's their daily exposure, meters per second squared, A brackets 8. That's the one, that's the value. And that's the one that you want to be less than 5 and ideally less than 2.5. And you can either do it as points. When you get a copy of this presentation, you'll be able to see that, there's a points value. So 400 points is equivalent to 5 meters per second squared. 100 points is equivalent to 2.5. So you can do everything on points. Sometimes you can add the points up. It's just an easier way of doing it. It's all explained in the regulations. It's up to you which way you do it. But just to summarize, this is all about getting a hand-arm vibration or a vibration value and understanding how long somebody was actually using that tool for. But that spreadsheet's an excellent little spreadsheet. Loads of people use that. So to try to sort of summarize a little bit as we're sort of getting towards the end of the hour. What does the HSE actually say? Because it's important to understand where the HSE is coming from. Now, we have all got a duty of care to our employees, and you always want to do the best for them, but you want to do the best for them in the right way. So the HSE, you're not cutting any corners. So basically what they're saying is you need to identify where there might be a risk from vibration and who, i.e. the people, the individuals who are likely to be affected. That's the first step. And then you need to try to get a reasonable estimate of your workers' exposures. So this is what we've just been talking about. So say, well, how long are you using that vibrating tool for in a working day? What vibration value should I be using? And sticking those numbers in the spreadsheet, going through all the tools, how long they think they typically use them for. And you've got to be very careful because some people will say, well, I use that drill all day long. But when you look at it, they're only drilling for 5 seconds at a time, but they might do that 20 times in an hour. Therefore, you've got an idea of how long you're using it for. So you need to get some sort of a decent estimate. So therefore, bumming those numbers in with the vibration value and the timings, wherever you get that vibration value from, is something that is that then you'll get an idea of whether people are at risk or not. And once you've got that information, then you need to identify what you need to do as a company to make sure you're not breaking the law, to keep yourself right. So what that means is whether vibration control measures are needed, and if so, where and what they are. And then the next step, once you've done that, is to make sure you identify those specific employees who might need to be provided with additional health surveillance. And also look at any people that are particularly at risk. You may have people working for you that already have a predilection to these sort of issues. They might have Raynaud's disease or the start of it, nothing to do with vibration, but they might have some other health conditions that might be affected. So you're not just looking at whether somebody is overexposed or not. You're looking at that person more as a whole to see whether they might be more affected by the work that they're doing. So you need to keep an eye on them, and you might need to keep their vibration values that they're exposed to even lower than other people. And then finally, as I mentioned earlier, make sure you record everything. Make sure you put all that down. So the next question then is, what does that actually mean as a business to create an effective risk management strategies. So here are some examples of what you can do. One way that a lot of companies do this is they create a register of their tools. I had a question from Chris saying that, related to back of what I was saying a little bit earlier, in sort of car workshops and things like this. So some businesses actually don't allow any employee-owned tools on the premises. It's all got to be registered, and the company knows what tools people are using. So this is about creating a tool register, the make, the model, how it's used, what material it's used on, that sort of a thing. And then what you can do is, once you know what tools you've got that are potentially going to create hand-on vibration, then you can look at the typical vibration levels for that particular tool. So you can look at the manufacturer's data, you can look at other databases that I've mentioned, and then you can then look at whether you need to actually do some measurements or not. Because your tools will deteriorate, the vibration levels potentially might increase. And you're going to have a range of vibration levels that you're going to identify for those tools. And then what you could do is, you could mark those tools up as, you can use that tool for as long as you like, vibration levels low, or you can only use that tool on this material for as long as you like. Other tools at the other end of the spectrum, you might want to bin straight away, because the vibration level that, you're not going to do it just from the manufacturer's data, of course, but you might find that other databases, or when you actually measure it, those levels are so high, you're going to find that the people you need to use that tool to do the job just can't do the job because that tool is ridiculous. You can only use it for, 10 minutes a day. That's maybe not going to get the job done. So you're going to have to look at using or purchasing or hiring whatever new low vibration tools to get those jobs done. And you'd only know that if you'd done this piece of work. So you're comparing it, basically, those tools to the exposure values, and identifying which ones are potentially a problem. So you may want to put limits on it. You can determine, therefore, what the safe trigger times are for those tools based on that range that that those tools give you. Say, right, you can only use it for so long a day, and that's where you start to develop your sort of strategy within your company on tool use. So this is you starting to create a risk management strategy. Now, the other thing I haven't mentioned is really about other ways of doing the job, and it's all about sort of best practice. So this is the second slide on this. What you're doing is you're calculating the individual risk based on an estimate of the measured amount of tool time use. And then the idea is that you put in a program for the use of those tools. So this is just taking it a little step further. So it's all about looking at the best practice for those tools. So, how are they best to be used? How can they be held? Is there any other additional equipment that could be used with it to minimize the contact with the tool, or to make that tool more effective? It might be you make sure that the working conditions are advisory for those particular tools. Make sure that people are wearing gloves to keep their hands warm, not so much for protection, but to keep their hands warm. Try to minimize working in cold, snowy, frosty, wet environments, those sort of things. And making sure that everybody starts reporting when they have issues with tools. So if something starts juddering a bit more, or it's taking longer to use that tool to do a certain job than before, that is, and all sorts of things like this, that's an indication of when tools are starting to deteriorate and potentially have higher vibration values. Because the people using them every day will know, but they need to make sure they don't just put up with it, report it, make sure that somebody's looking at it, use a different tool, because you will not know second to second, day to day, whether those vibration values are getting any higher without the cooperation of the people actually using the tools. So that's why you need to get them on board. One thing that is key with all tool use is make sure that they're serviced regularly. That's one of the major things to make sure that tools are not necessarily tested, but some companies do have an annual or a twice yearly, not twice yearly, biannual testing of all of their tools to make sure that the vibration values haven't sort of shot up or are crazy. You may or you may not need to do that, but the one thing you do need to do is to make sure you have a very good service or maintenance schedule on those tools, and encourage people. It's all right saving money by just drilling a little bit longer or using a disc for a little bit longer, but believe me, that's when those higher vibration values can kick in to make sure they're using the right bits, and they keep them serviced regularly, and that is another way of very easily making sure that it's minimizing the extra vibration that people are going to be getting by using these tools, because there's no getting away from it. Using a hand tool, you're going to get vibration because you're holding it, and if you're putting it in a frame and using a frame, that will minimize it. But basically, it's not a hand tool anymore. It's something else. But so people are going to get vibration. Make sure training, as we've mentioned before, is part of that risk management strategy, and again, health surveillance. I keep banging on about that all the time, because it's just a key thing. So we're coming to the end of the hour. I've just got one more slide I wanted to share with you before, if anybody's got any questions. It's a good time to get them in now, and I shall go through them if there's any there. But I've got a couple of common questions that people ask with this topic. And the first one is basically, do I need to measure? Right. And the question is, you don't have to measure. No. The HSE isn't saying you need to measure your tools. So what you've got to ask the question is you can look for that data, and that data is available as the various databases, or there's the manufacturer's data. And you've got to ask yourself the question, why am I measuring? To what purpose am I measuring the tools? And that's because you will believe that the data you've got, either you can't find any, or the data, you're not quite sure whether it covers all of the aspects of the way you're using your particular tools. So where you are measuring, if you do want to measure and get an actual value from the handle of the tool, is you're measuring on the tool handle. So the hand-arm vibration meters will sit as a small square, usually accelerometer, strapped to the handle of the tool. You get somebody to do some sample drilling, some sample work, and then what you'll get is some vibration values. But as I said before, you're going to get a range of vibration values depending on what so every time you do a run, you're going to get a different value. It's going to be slightly different. It should be still in the same range, but you could get a wide range there. But that you only measure really if you were unsure about the level of tools that you've got, and you're doing something a bit different with them. And really, if you are measuring, you are going to get peace of mind. You do need to make sure, though, that you get somebody in to do that measurement, or the person doing it in your own company has a good understanding of what they're doing. Because there's such a variability, they need to make sure that they understand exactly what they're doing and they get that good wide range of data. The other common question is about PPE. Is it suitable? And I'll say this again. I've said it before. Basically, there's no PPE that is suitable for reducing the risk of hand-arm vibration. But what you can do, as I've said before, is to keep your hands and your body warm and dry, which will mitigate that risk a little bit. You're less likely to have damage if your hands are warm and dry while using vibrating tools than if they're cold and wet. That's where PPE comes in. And then the final thing I just wanted to mention on here is about vibration values. They are a range. It does depend upon the material, the person using the tool, how good the tool is, is it, brand new, is it 10 years old, and what accessories, drill bits, etc., etc., you put on there. So it's not quite simple saying, I can see a number, that's what it is every time. It's not like that. There's always a range. So just bear that in mind when you're trying to do your calculations, working out whether people are at risk. It's always better to err on the side of caution and to use the higher vibration values in that range when you do your calculations. So that's me finished. A big thank you to all of your time. I shall put me back on so you can see me. So it wasn't a recording. I was really there, looking or not. So if anybody's got any questions, please let us know. Now we've got a little bit of time to answer some. As somebody said, you will be sent a recording of this webinar. It'll be hopefully later today. Everybody that's registered, and even if you weren't able to make it, you'll still get a copy of that. And if you wanted sending to anybody else, just let us know. The one question I had was, I think I mentioned it already, that some companies don't allow any employee-owned tools, so they manage that risk by making sure that every tool belongs to the company and is checked and is tagged in some way so that they know what the potential risk of using that tool is. So Nicholas has said, we have been advised by the HSE a 5-minute trigger time to 10-minute rest time. I mean, that's really good. So, they're having a rest, using it 5 minutes at a time, I guess, Nicholas, resting for 10 minutes. And obviously you could sort of calculate whether that, so basically what that means is in any 1 hour, if somebody's using a tool constantly, what's that? You're basically using it for 20 minutes an hour. And you could put that number in that spreadsheet that I showed you with the vibration value, and that will tell you whether you're exposing people. So you can do that little bit of a calculation yourself. Good question from Jess. If an employee has a pre-existing carpal tunnel and we find out via health surveillance and is on the tools, is this then RIDOR? That's a very good question. I'm not sure, to be honest with that. I think if somebody's got pre-existing carpal tunnel syndrome, it's not something that's been affected. I wouldn't have thought it is RIDOR reportable. You would probably need to check on that, maybe with the HSE itself. But what I would say though is, if somebody does have that and they're using tools, I would make sure that you completely, you make sure their vibration level, their exposure is as low as possible, because obviously somebody with a pre-existing condition, this is only going to exacerbate it. So I would minimize, to be honest, any vibrating tool used for that person, get it down to as low a level as absolutely possible. Another question, a lot of garages will supply higher vibration items such as rattle guns. It helps with maintenance as part of the management. Yeah, rattle guns are particularly bad, both noise and with vibration. Just if I was an employee, I would want to know what the vibration value of these particular tools are, particularly the ones where I'm feeling it through my hands. Yes, it needs to get the job done, and you want to get it done, but you'd want to know what the levels are and how long you're recommending as an employer you use that tool for in any one particular day. A question from Christopher: is it necessary to measure every worker on each tool? No, it's not necessary to measure every worker on every tool. But I would say use a couple of different people just to see if you're getting a range. Some tools will be the same no matter who uses it. Other tools, depending what they are, you will get a slightly different. So somebody's just, maybe they've just got softer hands, or they're just a little bit more efficient, or they just know how to use that tool better, or they use a different speed or whatever else. So as long as to get that range, at least a couple of different people, 2 people, I would say, if you're going to do a measure, that should be fine. Well, we've got another question from Sarah. Right, handling impact of personal lives on vibration. Yeah, this is a good one. So you've got people who are using hand tools at home. They're doing a lot of DIY, etc. They're they're doing all sorts of other things. It's out of the scope of work exposure, yes, because you cannot manage that, but that could cause them problems with their health, and that's where the health surveillance, keeping an eye on how people's hands are getting to the report early symptoms, is a key thing. Once they're involved in the training and you're telling them all about it, and they might come to realize that what they're doing at home is providing a risk to them. You can't force them to tell you, obviously, what they're doing at home, but they might come to realize that they may need to do some work or minimize what they're doing themselves because they can see the damage. So yes, it's your key focus is what they're doing at work, but yes, have an eye for what they're doing at home, because you might help somebody avoid a health problem just by giving them this extra information. Okay, is there any other questions from anybody that's online? I hope you've enjoyed this webinar today, and it's been useful to you. You, as I say, you'll all get a link to the video, so you can watch it again or pass it on. If you need anything else from Cirrus Research, slides or anything else, or some advice, please just give us a call, or go onto our chat system or whatever. We'll try to help you any way we can. So thank you very much. Thank you for all the thumbs up, etc. I appreciate that, and hopefully we'll see you for the next one. We do have another webinar coming up next month, Jamie, I think, on our noise tool software, if that's of any interest to you. But and then that's with my colleague Richard. But and if you've got any suggestions for webinars as well, just let us know and see what we can do. Thank you very much. Goodbye.